this has been a little bit of a process, but as some of you know, I have a Mytee brand carpet extractor, and I wanted to put better components into it because the shampooer itself was only 50 bucks. So I figure, I have a shell that I can work with, and I figure I just put better components into it because the original motor was a 3-stage 5.7 motor that had, I want to say it was only rated for about 100 CFM. And this motor is a 6.6-inch motor, and I think its ratings are somewhere around 130. I think it's around 130 for both suction and airflow. But it's been kind of a process with it, because I ordered this motor from Cobb Carpet. It's like they had a good price on it, and they were saying it's comparable to the Rotovac ZX. It's not exactly the same as the Rotovac ZX motors, but it is pretty close. So it's like, okay, that's fine. It's quite a bit cheaper, and they'll actually sell it to you. Unlike Rotovac, where you have to like have a machine that takes the motors, provides serial numbers. At least I think so, or maybe that was Mytee's LX motors. Well, regardless, I ordered the motor mount or the manifold for the 6.6-inch motors, and it was out of stock and discontinued. So it's like, oh, great. So I spent a while looking at other options for it, and I came across another one also through Cobb, which was made for the 6.6 or 8.4-inch motors, because I guess it must have had multiple mounting patterns built into it. And guess what happened? Discontinued. So it's like, great. Now I have this motor, and I have no way to attach it to the machine. Because I know many of them, many motors that are made for carpet cleaners have a stub that comes off of here for you to clamp a hose right onto it. Well, they didn't have from what they told me, they didn't have a welder that could like attach the fan case with the tube to it at the time. So it's like, okay, so, I had no way to mount this. I was not too happy about that, but recently I couldn't help but think to myself, could 3D printing be an answer to this? So I looked up a local business called Vector 3D, or I should say around the area. But this guy, he's been great. Because I just kind of got some feedback from him. I did the design on this thing through Tinkercad. Very, very accessible to like the beginners. You can just place some shapes, and once you play around with it a little bit, it's really not too difficult to do. But I had the guy over at Vector create a scan of this motor. So then once I had the file he created, I used a mesh mixer, I think, in order to, just get down to this, the bolt pattern on here. That way I could ensure I would have the right spacing on here. So I used that in conjunction with Tinkercad in order to create this. And Tinkercad, like I said, you just place like cylinders or squares or whatever, and then you can it's actually really nice because you can just like click the figures there and like adjust them rather than just being able to drag and drop. Like you can adjust your height, so I made sure that everything was like the same height, by manually adjusting the numbers. Although, it's still not quite perfect because, there's a little bit of a lip here. Doesn't like to focus on this. Well, anyways, I got my basic design done, and then we had a little consultation with him because I'm totally unfamiliar with the 3D printing process. Because initially I had designed this with this tube built onto here as part of the unit, but what he had told me was due to the way they print, and because of the higher heat, there's a chance of deformation with the ABS material which this is. I figured, a higher strength material might be better for this because it's going to be bearing, the full suction of this motor. And I'd rather not have it like collapse. But he told me the ideal printing method for this would actually be to print it upside down so it has a solid platform to work off of. So he suggested that the connector here actually become a second piece. And it's like, well, you're the expert, so I just did what he told me to, and just created a little bit of a lip there. So all I have to do is put a little sealant on there. Although he mentioned this, that it was going to be a really tight squeeze right there, but after so many revisions, it's just like, whatever. It's like I can always turn it just a little bit because this will eventually be sealed onto here with something. And there's not a huge amount of wiggle room here. I designed it to be pretty tight. So it'll be sealed in here in some manner, and there's room for it to be swiveled a little bit, so that's not a huge deal. Otherwise, if necessary, I could always just cut a piece of that off. But yeah, I just have to get a piece of sheet metal to put under this so it has a nice solid platform, and I think I'm going to use a piece of I see you can get some like thin like rubber gasket sheets, so I figure I'll put a piece of that between the manifold here and that motor housing, just to make sure I have a complete seal. I mean, it seems pretty flat, but he mentioned that there was a slight amount of warping, at least on the top of it. I can't really see it, but yeah, I figure a little bit of sealant on the underside would be a good thing. But yeah, I'm excited to finally have a way forward. It's like I can finally put this motor to use, and I'll be sharing this design so others can potentially use this if they so choose. Although I know a lot of, like professional carpet cleaners would rather use a two-motor system, but, for the average, well, I shouldn't say average person, because I mean, who besides somebody like me is going to have, a professional carpet cleaner? But, it's like I figured somebody out there is probably having that same problem, so it's like, I'm putting this design out there, and, whoever can use it. And yeah,